Welcome, everybody, to our session on work, on AI and the nature of work. We were thinking this session through. We thought it made sense to have two very different perspectives. Somebody who's deep in the economics of it, in thinking about economic models of how machine learning technologies generally and language models in particular are affecting the nature of work. And then somebody who's actually tried to do it and implemented an AI in a way that requires a change in workflows. And so first you're going to hear from Dan Rock. I'm Avi Goldfarb, by the way. I'm a Rotman professor, for those of you who don't know me, and I hold the Rotman Chair in AI and Healthcare. I'm a marketing professor as well. So Dan Rock is an assistant professor at Wharton, and his research is on the kind of in the same, it's almost like the same sentence as my bio, the economics of digital technologies and AI, with this emphasis lately on how AI affects work. He's been widely published and widely cited in leading news outlets, New York Times, Wall Street Journal, etc. And what I find a lot particularly fascinating about Dan's work, but one thing that I find particularly exciting is this combination of an understanding of computer science and data science with deep economics. So it's not a lot of the people, no offense, okay, but who understand the AI, the technology at a deep level, have at best an undergrad level of economics. That's fine. We can't all be experts in everything. Dan is sort of on the opposite side of things. And the deep understanding of both the micro and the macro aspects of the economics I think have brought a lot of insight into our understanding of how AI is going to change the way we live and the way we work. So that's Dan. He'll come up second, but I'm going to introduce Frank now, just so that I don't forget later. Frank is a scientist at the Liechtenstein Knowledge Institute at St. Mike's Hospital and director of AI at Surgical Safety Technologies. He's associate professor in computer science at Dalhousie and U of T, co-founder of Winterlight Labs, faculty member and CFAR AI chair at Vector, and the inaugural chair of the Standards Council of Canada's subcommittee on AI. And again, the reason Frank is here is because he has tried to implement AI technologies into a workplace and had to think deeply about how to make it happen and face the frictions and barriers that we all face as we try to make technological change occur in a workplace. Now, last comment is, so far our norm has been people speak and then we all ask questions. That's not the norm in economics, and since this is an economic panel, I'm going to try to do a different norm. Okay, we'll see how it works, which is when you have questions, please put up your hand and ask them. Feel free to ask blunt questions, because that's what we do in economics. And it'll make at least for our style of presentation, it'll make things a little more dynamic and exciting. So please, as you have the questions, don't wait till the end, because you'll have forgotten them by the end. Ask them as they come up. That might mean our 30 to 40 minute presentations take a little longer. That's okay, because we'll have the dynamic in the middle. With that, Dan, over to you.
Thanks for that very kind introduction, and also thanks to the organizers, to Jillian for having me here. It's a pleasure to get to come up here and learn about a lot of different things that I hadn't thought about before. So I'm going to talk mostly about this paper, which we did a lot of work to fit the research into the pun that we put in the title. The paper is called GPTs or GPTs. That is, generative pre-trained transformers are general purpose technologies. And this work takes a lot of inspiration from work that Avi and his co-authors have done, trying to examine how big a deal precisely are large language models in particular, and perhaps generative AI more generally, for the economy. I'll show some results from some other work that I've done on other projects as we go through pending time. But yeah, this is, if we're thinking yesterday a bit about how we give or incorporate artificial intelligence into the capital H humanity tent, that's a much bigger question. I'm going to ask what's going to happen to accountants. So that's a little bit of a smaller smaller focus to some extent. So this is joint work. This main paper that I'm going to talk about is joint work with colleagues at OpenAI, Tina Londu, Sam Manning, and Pamela Mishkin. Actually, it grew out of the Toronto NBER Econ of AI conference. That's where we all met and decided to start working together. All right, so what we'll discuss today, how did we get here? What are these models doing? A little bit of that. I think this crowd understands that level of detail pretty well. Then I'm going to talk about what we're doing here. So our approach, it's a little bit something that we've done in the past. We're going to evaluate the tasks in the economy, or in the US economy primarily, for their potential to be changed by machine learning. And we use a rubrics-based approach. I'll talk about how that works. On the big punchline here, GPTs or GPTs, what is a general purpose technology? Well, it's three things. It's pervasive, like these technologies diffuse across lots of different places, and they affect many different things in different ways. They improve over time, which I'm mostly going to punt on that and just say it's obvious. These models are getting much better over time. But I'll show you some evidence for why we can expect that to be the case going forward too. And then the last thing, and probably the most important thing, GPTs spawn and require complementary innovation and investment in order to unlock the value. Okay, so as opposed to something like, let's see, what's a, TurboTax, right? Like that's a technology where it's a one and done basically, or a so-so technology, as Daron Acemoglu might call it. I just pronounced that wrong. I recently learned how to pronounce that properly and just pronounced it wrong, so I'm gonna have to go back and figure that out. But a so-so technology like a self-checkout line, that's not gonna affect the entire economy. It doesn't mean we have to rework everything we're doing or change our organizational structures to match what that new technology is doing. Things that take a long time because they're sort of inherently human and depend on changing human structures. That's for a general purpose technology, this does need to be done. And that means that it's a much bigger, much more impactful thing. So standing right now at the precipice of what large language models might do and saying, what's that gonna do to all of jobs writ large, is a little like asking Watt pumping water out of coal mines, what is the steam engine going to do to the world economy? And very long term, that's almost a nonsensical question. So in a sense, what our work is saying is like we have to be cognizant of our ignorance of what's going forward here. And I think that's a conclusion we took, large inspiration from what Avi and Florenta Teodoridis, Lady Tasca did in an earlier paper. So what we do find, however, is that about 80% of jobs have roughly 10 to 20% of their tasks exposed, depending on how you measure it. So many different jobs are going to change. The right level of analysis, the right unit of analysis is probably either the task, like you're looking at, jobs as bundles of tasks, we all do different things in different mixtures, or the full system where you say, okay, well, I don't think about automation at the task level or the job level. I'm not replacing these jobs. I'm changing entirely what I'm doing, and that new set of things that I'm going to do has different demands for what people do. So, focusing on which jobs are going to go away. Our paper's been used in a few clickbaity kinds of articles to say, like, the AI is coming for your work, and it drives me nuts every single time. If I had hair, I'd pull it out. But it's a sort of frustrating thing to say that. That's not what we're saying. We're saying there's task exposure. Things are going to change. We can provide a little bit of a roadmap for where they're going to change, but we don't know exactly how. All right, so these IT-based job displacement arguments are not new. There are many things about large language models and machine learning in general that rhyme with older waves of technology. All right, so we saw with earlier waves of IT, think about coding up recipes for how you process data. Routine work, that kind of doesn't grow as much anymore. So this is like David Otter and co-authors' work. Non-routine cognitive jobs have grown to be a larger and larger share. We've seen polarization in the workforce. The top end of wages is pulling away from the middle, but there's also like a growth of lower end wage work. Non-routine manual work has gotten more important too. So you can think of some of these new machine learning models as unlocking recipes for tasks that didn't exist before. So, yeah, question. Sure. So routine cognitive stuff, I watched like a YouTube video of what offices looked like in the 90s. You know, I was 2 years old then, but like early 90s. But I was like, wow, there was someone who would take files and put them away in drawers and have to retrieve them. Now that's software, but it's the same thing every time. I want this file, go retrieve that thing. Actually, in my first job on a trading floor, I did a lot of this like manual checking of what people did. Very much a routine cognitive kind of job. A non-routine cognitive job is, you know, develop a new reinforcement learning algorithm. That's not going to be the same every single time. You know, so there's a lot of, as I'm sure Frank will tell us, there's a lot of art to training these models, right? So that's not the same every single time, even though there are things that kind of are the same as you do it. And then a routine manual job might be check if you're in like a factory, like say you're processing tomatoes or something, like check the tomato for defects. Non-routine manual would be like, oh, I call an electrician, there's something wrong with the electricity in my house and I need that to be fixed. So that's kind of a blend of cognitive too. But that kind of makes sense for everybody? Cool. All right, so the non-routine or the routine cognitive work that wasn't exposed to this sort of automation though in the past is stuff like, you know, recognize your mother. Like you can do that instantaneously. It's not hard for you. It could be routine, but if you know, were asked to do it, like how would I describe doing that? It's very difficult. You can't say exactly, okay, these are the things I look for when I try to recognize my mom. That's the fact that we know more than we can tell, Polanyi's paradox, a lot of these models kind of unlock that, that set of work. So that's one way of thinking about it. So okay, that's why it might be the same, or high level why it might be the same. Why is this time different? My co-author, former advisor Eric Brynjolfsson likes to say this is the most G of all GPTs. There's a lot of general purpose like mimicry of the cognitive processes that people might be doing at some very high level. You ask CS researchers, you know, what's the timeline for full automation of all labor? There are people who say it's not too far off. I mean, when I say not too far off, there's like some folks who say it's like 75 years. I think you widen your confidence bands maybe based on what we've seen recently, but you know, as a stodgy economist, I'm going to say I don't think it's like full automation of labor is coming soon, and I'll explain why. All right, so on the other hand, some interesting things that are new. For those of you familiar with Auto GPT, I'm really glad that you know, these technologies are not as powerful as they might be in the future, because when you make this available, you know, you can give Auto GPT high-level goals. It tries to accomplish them. Someone said kill all of humanity, and Auto GPT is trying to do that right now by tweeting. It's nice to know that someone gave it that goal, because then when something more powerful shows up, maybe they'll do it again. But for now, you know, well, if it manages to kill all of us with tweeting, I mean, I'm kind of I'd be surprised. But this is a new paradigm, right? This is new stuff that nobody was thinking about before. So, all right, what are we going to do? Well, we're going to take that task-based approach. We're going to look at the US government puts out about 20,000 tasks, and those tasks describe the bulk of work that people are doing in the US. It's a lot of ethnographers going out, surveys, and so on, building this taxonomy. And then we're going to ask a very simple question, which is, you know, can a large language model either double your productivity in doing this task, do nothing for this task, or yeah, you could double your productivity doing this task, but you would need to invest in other systems. You need to put other systems around it in order to deploy it. So that's going to help us test this hypothesis that GPTs are GPTs, because we can see, okay, where can you double your productivity in the task, and why do we pick doubling? Well, it's pretty easy for a human to understand, like cutting the time it takes to do something in half. So we're going to have humans rate it for that. These are people who have expertise in how these large language models work. They've been working with OpenAI to kind of evaluate what the models are doing. But then we're also going to ask GPT-4 to evaluate all these tasks and see what GPT-4 says. By keeping this prompt simple, we can see, all right, which are the tasks that are exposed? Are they concentrated in one area of the economy? Are they widespread? And then by comparing, okay, yeah, you can double your productivity versus, okay, yeah, you can double your productivity, but you have to make all this additional investment, build up a whole bunch of other systems, then we can see, is it going to require complementary innovation, at least via the labor market, right? So there's a whole capital market, there's a whole organizational setup. This is one narrow slice, but it's enough when we look at that to say, okay, this is a a really big deal, and it's going to require complementary innovation. So that's the hypothesis we're testing. And then we're going to do a bunch of validation, summary statistics, take a look at where this stuff's going to happen. So I'll tell you who I think is exposed to some of this stuff, and maybe some of the differences between automation and augmentation. So I said I'm going to punt on that question of are these things improving over time? Why? Well, I mean, look at what variational autoencoders can do, or I think the last one's actually stable diffusion, but. This is, in 2014, I saw this and I was like, oh my God, like AI models can build plausible images of faces. And then now it's like, okay, models might be in trouble. Like we can build very plausible images. And obviously there's great stuff in all sorts of image generation things. You think about, this is something my co-authors taught me, maybe intuitively obvious to many of you who are AI experts in the room, but I found this helpful. I asked why, like what's getting better here? And they said, well, it's two things, and one of them is not really as important now as it was in the last few years. The first thing is scale. So GPT-3 to GPT-4 is a massive increase in the number of parameters. That scale lets you model things much more flexibly. You've got the universal function approximation stuff. All of that's working for you. Now, what I've been hearing lately is that the scale is not needed as much. It's like these models are actually sort of inefficient in how they get to these results. So a lot of the effort now is making them more efficient, and scale is less important. It's also very expensive, bad for the environment, and all that other stuff. So the more important thing comes from reinforcement learning with human feedback or AI feedback, whatever kind of feedback you want, the important parts of the feedback. If you can generate 1,000 different outputs that are text or image or whatever you want to do, the important thing is knowing which ones are good or bad. So by incorporating this feedback process, you give models taste in a way that they didn't have before. And that's new and very exciting. So to have taste, to have preferences, and maybe that preference is just to make us really happy. Like that's why hallucinations happen. It's not that it's trying to lie to us. It's just trying to make us be pleased with the output. I think that's good because we can tune these things, but it also, from a labor market perspective, becomes very interesting because there's all sorts of places where you need taste and judgment, as Avi and his co-authors' work has taught us, right? So, talked about these criteria, so let's get into what we did. Here's just a little bit of a view of what these tasks look like. In case you're like, what does it look like when the government tries to figure out what people do at their job? Imagine that like office space thing where the consultant's sitting there like, what is it you'd say you do here? Then you go through, it's like, well, a gambling cage worker executes sales or other financial transactions. It's like a detailed work activity. It's a general shared task between lots of jobs. But when you go to the gambling cage worker specific version of that, it's cashing checks and processing credit card advances for patrons. That's a little disturbing, credit card advances at a casino. But maybe you want to kick those people out of the casino, so whatever. There's about 20,000 of these tasks. The activity is the more general thing. There's about 21,000 of those, or 2,100 of those. All right, so we're going to go through each one of those, and here's the question we're going to ask. First, we say in our prompt, and this is to humans and to GPT-4, does this have no exposure? Can LLMs not help? Yeah, Jillian. Sure.
There we go. There we go. I got it. Okay. So cash checks and process, and you kind of, in a sense, reference it. That person also needs to deal with the public, deal with their managers, schedule time, keep their coworkers happy by not putting things in places that they shouldn't be, Sheila. Oh, no, Sheila studies that. She doesn't do that. She studies that. So I just wanted to, just on that task description, if we're going to say that's what it is to be there's a whole bunch of stuff that's not in there.
Oh, totally, yeah. So very important point and great question here. So each job is about 20 to 30 tasks on average that people do. So you can imagine that diversifies you a good amount from like a technology that can't run the table. Now, Gen AI does, in exposure terms, non-automation terms, run the table on a few jobs. Actually, it was funny. When we released the paper at first, people were like, you said mathematicians are fully exposed. that can't be true. It's bad at math. And then like sort of like the SpongeBob meme, like 4 days later, and like the Wolfram Alpha plugins coming out, and all these people doing math are improving what they're doing and like iterating with. So we're like, okay, yeah, I think we were okay with that one. But yeah, so like when Jeff Hinton said in 2016, all radiologists are, should be looking for other jobs. That's one perspective. But if you look at this data, there's 30 things that radiologists do, and 3 of them were exposed to supervised learning. There's a lot of other stuff. So a perhaps more useful way to think of radiologists, whose demand has gone up, like demand for radiologists has gone up since then. More useful way to think about them is data-enabled doctors. And from that perspective, it's clear that they were not going away anytime soon. Of course, maybe scanning things, maybe they specialize in weird scans instead of like the, oh, yep, that's a broken arm kind of scan. But yeah, there's tasks or jobs are bundles of tasks in that sense, yeah.
Sorry, just so I understand how this table works. So if it died, sorry.
The table? Oh, whoops. No, I don't know. Let me.
Well, basically, the 2 descriptions of kindergarten teacher accepting special education needs, they're both the same, I think, or something like that. So I was just wondering, and they were also very weird, which I think is part of what.
Oh, yeah, that is a duplicate. My bad. Yeah.
Is that just.
These are just cherry-picked examples.
Okay, but so it's not a weighting of like the importance of a particular task of a teacher or something?
No. In fact, we weight, the government says like these following 19 things are core and these like 3 are supplemental. So we weight the core things.
Okay.
But I think it's a good point. Like in each case for each individual, the weightings on these tasks are going to change a little bit. In some cases, they're going to be 0. Like if you're inspecting defects in fruit or something at a factory and someone replaces you with a machine vision system, you treated people like machines. So, you got what you pay for it in a bit, or in a way. But yeah, all right, this is back up there. Cool. Okay. Yep.
Okay. Which is these tasks, or the WAs, these aren't things that could be executed by a machine per se, I think, right? You need to,
No.
They're still pretty high level.
Yeah.
And I don't know if you've seen, so Kindred, do you know the company Kindred?
Yeah.
So Kindred, we just saw a presentation last week where they're working on using GPT-4 to unpack the tasks into the subtasks.
Yeah, stay tuned on that one. I think we had a similar idea for a research
so
project. That works super well. So you can ask GPT-4, like, give me 5 subtasks for this one task, and it does it exceptionally well. So in a sense, like the task is McKinsey analyst, give me subtasks for this job, and it might take them a couple days, and GPT-4 does it in a few seconds. So, also to your point, the reason that these are shared, I forgot why we put these the same thing. I was like, I know there was a reason we had the same thing. The task is the same, but the kindergarten and elementary school teachers both sharing that task. So sometimes there are duplicates of the task there. Yeah. Okay, so it takes me until about 1 in the afternoon to wake up properly and then actually figure it out. All right, so we say no exposure, and Avi, wait, actually, quick question. What time, how much time do we have here? It's like another 20 minutes or something? Yeah, what time are we?
15. You got 15 left.
15? Okay,
Yeah.
cool. All right, so we're going to say no exposure if you can't double your productivity or, in any way, shape, or form with this stuff. And that shows up for short order cooks and a lot of physical work, stuff like that. Direct exposure if you can double your productivity, and LLM plus exposed, or we call it E2, if you could, but you need this complementary investment. You need to do other systems to go with it. So here's what we get, at the occupation level between GPT-4 ratings and
Sorry,
humans.
can I-
Yeah, Jillian, go
We're
ahead.
going to give you a 20 to 25.
Because you encouraged us, so
no,
we're
absolutely.
doing
It's
it.
awesome.
Yeah.
I love it.
So I just want to go back. So the direct exposure, so we've got this, it's going to reduce it by at least half, 50%. Where
So-
does that come from?
That is
Who's doing that estimation, that this task could be decreased by 50%?
the time it takes to do this task is dropped by 50%.
No, I understand what it means. I'm just
Yeah.
wondering
Oh, got
how
it.
you coded that, because you didn't run all these tasks simultaneously. Give it to a human, see how long it takes. Give it to the machine, see how long it takes.
Right. That would be the best thing to do is,
We're trying to do that.
Yeah, and then the machine's like, I can't do that. 20,000 different systems. Okay, we could try to automate everything in the economy, but what we do is we give it to the 6 or so OpenAI raters. We rated a bunch of these tasks ourselves, and then we load it up as a prompt into GPT, have those scored. The 50% number came from, if you said 10% versus 15%, 25%, people had a hard time kind of conceptualizing that. But if you said, could I do this in half the time, would it be really helpful? Then people had a better sense of, they gave us better answers, basically.
But it's still a guess, right?
Oh, totally, yeah. This is sort of arbitrary.
I just want to make that.
Yeah, for sure. Yeah. And GPT is better at making these distinctions. Like if you run it with 25% versus 75%, you can kind of get a gradient. There's noise around it, but humans, not really. It's not as easy to separate out. I have sympathy for that. I can't do it either. I don't know. But when you run this, we got human ratings on the x-axis here, GPT-4 on the y. This is a bin scatter. People tend to agree with the machine, which was encouraging because I think that unlocks a whole bunch of uses of GPT-4 to the extent that people agree with machines, and GPT-4 can make these judgments a lot faster. I've run some of these things with crowd workers before, and it'll take you 3 weeks and cost you $20,000, and GPT-4 will take you roughly 8 hours and cost you $20. So, you can spot check, use statistics to your advantage here, and see how quickly you can get within a tolerance. GPT-4 actually tends to be a little bit more conservative in some areas too. Maybe it just doesn't want to do that work, so it's telling us it can't. But humans have a little bit more vision about what these systems might be able to do one day. So that shows up in the E2 side. Another way of looking at that, so we actually ran 2 different rubrics for GPT-4. You want to see how brittle these prompts are, and the answer is they can be pretty brittle, so you have to try a few different things. If we put the suggestion default to E0 at the beginning of the prompt versus the end of the prompt, it tended to rate more things as E0 at the beginning of the prompt. So each of these columns are going to start with the human column, go to our first GPT-4 rubric, which sticks that E0 thing at the front, if I recall correctly. Or maybe it's the back, I forget. But the second one flips that. And you can see, if you squint at this thing, the sanity check is most of the blue stuff on the top, most of the yellow stuff in the middle, most of the red stuff on the bottom. Because this is where the disagreement flows from human to other places. And what I wanted to see in this plot was that the red stuff did not show up in the blue stuff very often. And there's a little sliver of this kind of stuff. And that's where, these tasks, I don't think they're super well rated. But the other places, like the E2 area, could I build an additional system with a large language model to double my productivity? Reasonable people might disagree in that area, whether that's fully exposed or not exposed at all. So yeah, it's not perfect. There's noise in there, but this is one way to start getting guidance as to how the economy might change, because as we aggregate from tasks to jobs, from jobs to firms or industries to the whole economy, you're squishing a lot of that noise out. Okay, so, yeah, question?
Sorry, clarification question. Sorry, so the human raters, can you just explain who the human raters are again?
Yeah, they work with OpenAI. They evaluate, they help with that reinforcement learning with human feedback thing, as I understand it. They're very well familiar with what large language models can do. They are not the people doing these jobs. It would be great to have nurses rate all the nursing tasks. It'd be great to have salespeople rate all the sales tasks.
Okay.
But they don't have special expertise in this work. Yeah. All right, so what do we find doing all this stuff? This is kind of what we did. Well, all right, first of all, large language model exposure is pervasive. The average task has 15%, or it's 15% likely to be something you can double your productivity with just large language models. That average scales, as you'd expect, to the occupations as well, because occupations are built up out of tasks. Though the variance collapses a bit when you go to occupations because of that diversification benefit. So maybe a little bit hard to see, but okay, who's heavily exposed? We have 3 different measures of exposure. E1 is to say these are only the tasks where you can double your productivity with just large language models. E1 plus E2 is like the most permissive definition. We're going to say anything, whether you have to build other systems or you're good with just this, like, you know, we're going to say all of that's equally exposed, and then we kind of prefer to use the E1 plus 0.5 times E2. That is, you get half credit for full systems you have to build, but large language models out the box still count for more. So depending on which one of those measures you pick, you get slightly different mixtures of who's mostly exposed, and whether you pick humans or machines, so there is a lot of agreement. Like blockchain engineers are highly exposed. Sort of surprised that's a job, but you know, I guess the hype machine got to the ONET people. Then there's you know, proofreaders, clerks. There's a lot of, you know, where's Polly? Polly, there's poets on this list. Might not be surprising. You can use these things to help with poetry. Interpreters, survey researchers, mathematicians, people who process information, you know, people who have knowledge as part of their work. So that leads to, you know, kind of this result, which once you see that processing information is the key thing that's being done, and maybe that's obvious ex ante, maybe not for me, but for others, you get this result that while the counts of people employed in each one of these jobs are not super correlated with exposure, those are the top two sets of graphs, the bottom two, here we've got on the x-axis the log annual wage, and it's the higher wage work that's more exposed to large language models. Yeah. Avery, you got it.
I just have a question about poetic productivity.
Mm-hmm.
I'm understanding this to be talking about how much time something takes.
Right.
Am I right? So nothing about the quality.
Oh,
And
I can't believe I forgot this. No,
Okay.
we specified in the prompt it was without a drop in quality, that you could cut the time in half. Very important. Yeah, I can't believe I forgot that. Yeah.
Okay, wow.
So-
Now I need to think about, 68% of poets have no drop in productivity when they have an E1 exposure to. That's very interesting.
Yeah, their productivity will increase quite a bit using large language models. Now, one of my students is actually studying academic work and the launch of AI tools, and he doesn't find a productivity increase in terms of counts of papers. And that might be because people just make the same number of papers, but they change what they do. I imagine poets might be something similar, like actually in the wild as opposed to what these results are suggesting.
Poets in the wild.
Yeah,
Okay.
right. Yeah. As opposed to, you know, yeah, Polly's back there. So, on the other hand, like, I've never written a quality poem in my life, and maybe I could do one in the style of Taylor Swift now, so, you know. It's, yeah. So E0 is the I can't use large language models at all. E1 is I can double my productivity without a drop in quality using large language models alone. And E2 is I can double my productivity using large language models plus other software and systems. Yeah. So this is new. Like, we haven't seen a technology where the highest wage jobs are more exposed than the low wage jobs in this way before. And that's, I think, why people are getting so spooked about it in the media and other places. There's a lot of powerful interests that get challenged by this kind of technology. That doesn't mean it's bad for them, by the way. Like, exposure could be great. It could be that you're the best engineer in the world, and this coding tool just made you twice the best engineer in the world. So, you know, I don't think we should perceive it to be that way. You see this like with barriers to entry for jobs too. So these are using these job zones that the BLS puts out. The higher, like this orange and yellow group was more exposed than the other groups. Those groups are ones where there's a lot of occupational licensing, a lot of education, a lot of barriers to entry for those jobs. Things like lawyers and pharmacists, they're more exposed than folks who, you know, do landscaping or something like that. So that's also kind of new. I'll skip over that because it's just restating the same point. These are much smaller than I expected them to be. But, okay, so I can tell you what are the top exposed, this is industry plots. You can get a relative sense of the most to the least exposed industry. That's like 0.2 at the bottom and 0.6 over here. The highest exposed industries, things like data processing, information services, insurance carriers, credit intermediation, which includes all the banks, professional and scientific services. On the other end, least exposed, social assistance, food services, agriculture, wood products, that's a favorite industry of mine, and nursing and residential care. All right, so the types of work people do changes how pervasive the impact is going to be. But you're still seeing really pervasive impact across a lot of different industries. All right, so there's this concept in economics called Baumol's cost disease. We're definitely seeing it in the economy. Healthcare, education, housing, things that were really bad and not productive at producing grow to be the largest share of inputs in the economy. Because if you're really productive, like we're super good at making corn, and corn production is no longer a big part of the economy. There's only so much of it, we eat in the developed world and so on. So there's a bit of a concern that though pervasive, the impact is going to be targeting industries that have had high productivity growth in the recent past, which means you're not getting any help from large language models to improve productivity where we need it the most. We see that there's no correlation really. This is the scatter, employment on the x-axis, productivity growth on the y-axis, colored by exposure. It's all over the map. So housing, education, healthcare, those are things that might actually benefit from large language models. That's pretty exciting. Hopefully we can start delivering some of those educational tools we discussed yesterday, reformatting how we do things to teach people. Certainly I'm starting to do a little bit of that in my classes, but we might not see those gains for a while. One of the reasons we don't have timelines in the paper is because my co-authors and I disagree on this. There's a lot of opinions there. I think it's going to take a while. All right, so then on that question of complementarities, how long does it take to build those other investments? Depending on which one of these measures you use, whether it's the E0 or E1 on its own, or E1 plus 0.5 times E2 or E2, you get very different measures of exposure. So what that means is that the complementarity piece, what other investments you make at the same time, is super important for understanding how exposed people are, which means we have a lot of building to do. If we want to deploy these models, there's other systems, things that have to change. So pervasive, yes. Improving over time, assumed, and requiring complementary innovation, also true, all right, at least from what we can see here. So if that's the case, we've got the case that it's a GPT. And then we have those other, those follow-ons from knowing something's a GPT, which is basically that we don't know a ton in equilibrium. All right, so let me, these are the most exposed roles. I talked a lot about exposure. Exposure is like generally not good or bad. It can be helpful, it can be hurtful. You look at this list, you get mathematicians, you get like physicists somewhere on this list, software developers, bioinformatics people. Then you get data entry keyers, correspondence clerks, and so on. There's like two mixtures of things going on in there. So we built an automation rubric too, and this isn't something I've talked about a ton publicly before. But if you put that list alongside the list of the most exposed to automation jobs, you get a different list. And in particular, what it does is it takes out a lot of that knowledge work. So we get back, that is, the list of most exposed to automation jobs are things like telephone operators, word processors and typists, bookkeeping and accounting clerks. This is where routine cognitive work, the old story of IT-based automation, comes back. So we've got a few things going on with these technologies, and it's not purely one story versus the other. On the other hand, when you regress exposure on automation, they're highly correlated. So the R squared on this regression, this isn't the regression line, it's a 45-degree line, but the coefficient's 0.94. So the R squared is about 46%. Okay, so automation exposure explains about 46% of exposure. It tends to show up in a lot of the same places. You get good exposure, you get bad exposure, with the residual as well as the automation piece. But it's not clear that things are going to go badly. I got about 10 minutes left, or? Yeah. Okay, cool. All right, so I punted before on timing. I'll come back to this automation point. Here's some evidence anyway. So these are GPTs scores for different models on a whole bunch of different exams. Most of them are AP exams. That big jump there is the bar exam. It went from like 10% to 90%, though I've heard that one get disputed, and it actually scores a lower 75% or something. Nevertheless, there's a machine that can get a 75% score on the bar exam. That's pretty stunning. These things are very much improving. And what I wanted to focus on for part of this to validate kind of externally that this development is happening is GitHub activity. All right, so we looked at forks on GitHub. We scraped a whole bunch of different repos and looked at how many forks there were, and we looked for ones that were had LLM content versus data science content versus other things. And right around the time that ChatGPT gets launched, there's a massive, massive explosion in open source development. It's like you took, hundreds of thousands of developers and all pointed them at the exact same task. To give you a sense of how big this is, it's like more than double the data science development that happened when COVID started and everyone went home and started working on open source code because they were bored. Like, this is absolutely enormous. Okay, so, the economics question, of course, is going to be what's the counterfactual. So I don't want to just do an event study. We can look at data science queries, like finding the data science relevant repos versus large language model ones is, again, just sort of visual evidence. Okay, data science doesn't really pick up in the same way. And then I'm going to do my favorite thing, which is synthetic differences and differences, which is a fun thing to do if you like algorithmically generating counterfactuals. But we do a difference in difference estimate. That is, I'm going to look at the change in time over two groups that are supposed to represent either treated by this large language model shock or the same but for that shock. So we have movement, in forks for, say, image processing repositories, but not large language model related repositories. They look basically the same beforehand. ChatGPT comes out, and only one of them takes off as a result. So we kind of get a guess of what would have happened if ChatGPT never showed up. So we run this 3 different ways, each one of them slightly more complicated in the modeling, but trying to remove some of the needed assumptions, relaxing assumptions to see what we got. We get basically the same number each time. So it's one of those things like when you're an economist and you're like that feeling when you don't really need econometrics. You can just look at the graph and be like, oh, it's up and to the right for one of these things. So the econometrics works when you don't need it. And the rest of the time you're like, okay, why am I doing this? So yeah, our treated result is this is explosive. There's tons of development happening. And then I think there's this question that many of you probably have, which is, okay, we ran this rubric, we scored all these tasks, we looked at all these different measures. How do we know that any of this actually worked? Like, that it's actually valid in an external sense? That's a question that nags at me every single time I do one of these studies. So fortunately, for pretty much the first time since we started running these, we actually have some results on that front. So there's internal consistency to the field, and I'll start there. So the field has been putting out, there's a ton of different measures from economists measuring exposure to supervised machine learning and other kinds of related technologies. So we're going to check that we're consistent with those. But, what we find is that on a univariate basis, there's some insight to be gleaned. Like Michael Webb's got a few different measures. One of them is exposure to robots. There's also the David Otter, Duro Nasmoglu routine manual measures. This is like how manual is your work. Strongly negatively correlated with what we have. So okay, that's a sanity check. And then depending on whether or not you control for wages, our old measure about suitability for machine learning, which was supervised machine learning focused, or the Felton, Raj, and Siemens measure, there's another one they have about AI exposure. Those are positively correlated. On a univariate basis, those two ended up tending to be the best. But if you throw the kitchen sink at this and you use all of them, the community does pretty well. In fact, we predict about 60 to 70% of the variation in these large language model exposures using the full combination of all the different things that people did in the past, which is great. Okay, so we've got some validity that this agrees with what everybody else says machine learning can do, but there's like a 30 to 40% additional variance here that has gone unaccounted for until now. All right, so then we have to get to the question, all right, so we agree with prior research, but do we agree with what's actually happening? And fortunately, when you work with OpenAI, they come up with creative things to do. They have a Discord with about 3 million people in it about GPT, and they ask them, what do you use GPT for at work? And we got around 1,000 responses. These are the things that those people said they do. So a lot of software engineers or programmers, some students, some teachers, visual arts people, data science, sales folks. And they told us, hey, this is what I'm using it for. So what we can do is score the tasks that they say they're using it for. We can put all of the tasks, the government and the ones that people say they're using it for, into a big embedding space. We use Ada. And then see, all right, let's light up that embedding space with our different ratings and see if there's overlap, or if there's overlap in bad places potentially. Yeah.
Can you imagine that there are, like, I think of it as overlapping Venn diagrams. So there are going to be people who use ChatGPT for their work, and there are going to be people who use Discord, but not in between. And so, like, I feel like there would be a major skew there between the people who are participating.
So there's definitely selection bias in the survey, but what I want to check for particularly is I don't want someone on this saying, I use it for this, and then I said in my ratings, or GPT-4 said in its ratings, you can't do that. Like, I'm checking for the negative space in a way, which, here's what people said. Here's a sample of these tasks. We had a bunch of them. It's like research new software design concepts. GPT-4 said, okay, sure, you can double productivity, but you need like a bunch of other stuff to do it. Humans said the same thing. Okay, nice. That seems like it's working. Compose and edit scripts or provide screenwriters with story outlines for which scripts can be written. Everybody said that's exposed to large language models right out the gate. Help children with homework and schoolwork. That's definitely something you can do right out the gate. Whole list of these different things. There were, of the things people said they were using GPT-4 or GPT-3 for, that on the Discord, only 3% of them were things that anything iterated as E0 not exposed. And that's what this looks like. So we do a T-SNE plot of this stuff. The gray things are things that are not exposed according to our model. The blue things are exposed to systems plus large language models. And the orange things are fully exposed to large language models with no additional systems. Those black dots are tasks that people said they were using GPT-4 for. And this is like an imperfect mapping. This is based on the Ada embeddings, and some of those, we're actually working on refining this because the language that people used on Discord is very different than the language the government uses, so you need to like do a little bit of translation. But for the most part, you don't see black stuff on this plot in the gray part of the graph. So there's signal here. We're picking up something. If very noisy, this is a first stab at saying, okay, we have actual external validation that people are doing things that we roughly said would be exposed, or at least we agree on what's not exposed. That's probably a better way of putting it. All right, so last couple minutes, there's a whole bunch of additional stuff in here that we could talk about for a while. I over-prepared slides here, but yeah, let's talk about what to watch for here. From producer theory, there's a whole bunch of different things that people say are important in these areas. And for a GPT, like a general purpose technology, where we expect everything to change, like you can think about augmenting labor, you can think about automating people. This is the big conversation everybody always has: augment, don't automate. As Avi, Joshua Gans, and Jay Agarwal have said in this recent paper, we should maybe think differently about how this could work. Automation's not bad for workers, and augmentation can be horrible for workers at the micro level. If you augment someone and they do the work of 30 people, and then everybody else gets fired because there's inelastic demand, that's not great. If you automate 20% of the things that I do in my job and I hate all of them, I'm thrilled. So like, this conception at the micro level is not useful. It's useful to policymakers at a government level. You're trying to figure out, do I tax capital or subsidize labor or whatever? Like, okay, yeah, we want to augment people so that they all have jobs and everything and they're more productive, they get paid more. But we need to make that distinction, because just as we can automate people, we can replace them with machines, we can create new tasks for people, we can augment capital, make capital much more productive and replace capital. And that one is almost never discussed. So if you listen to the folks saying we should tax the robots, you might end up actually hurting workers instead. There's a lot more work to be done. So at the macro level, how long does this take is an important question. I don't think we have good answers for that. How quickly are we creating new work? I'm working on some of that. I skipped over it, but I won't waste everybody's time with an additional paper at this point. And then at the micro level, where are these things getting deployed? We need to validate a lot of this stuff. So where is productivity actually improving? We've seen it for customer service agents. We've seen it for developers and sometimes for students. But as Joel and I were talking about this the other night, I think one of the key things for economists to add to this conversation is the idea of equilibrium. It's not just about replacement. There's complementary innovation that has to happen. There's change that has to happen. But even before that, you've got, what does the shape of supply and demand look like? What's the response on the other side of the market? If you make someone's work on one part of what they do very cheap, does that make the other part very expensive? And I think that gets lost in these conversations of AI is going to take all of our jobs. This is a really hard problem, and I think we mostly don't know the answers to a lot of these things. So looking forward to seeing more of that on the micro side too, like obviously the competitive dynamics of how large language model development work. Those are going to be super important for how this technology diffuses. So if you've got your eye on the ball, that's the place to look, I think, right now.
Okay, just a quick question because we want to get to.
Yep, I'm done. So
Sure.
I'll end there.
Thank you for this very interesting work. This may be a naive question. You've talked about the state of this kind of work. OpenAI is involved. In some ways, this kind of thinking is nascent. You said there's lots more to do. Could you help me understand how the decision to release 3.5 and 4 came before this work was further advanced?
I have no idea on that one, to be honest. So I know that we released this paper around the time that GPT-4 came out, and I had been, for all this research, whatever I was doing, I was working with GPT-4. So I'm not sure how launch decisions get made, though.
Okay, but I would say that, for what it's worth, when they came to our Economics of AI conference in September, pre-release, it was clear they were thinking deeply about these. I don't know how the decision made, and you may or may not like the balance, but this is not, the employment effects were not something that certainly your co-authors were taking lightly.
No, not at all.
Yeah.
In fact, we started this work trying to figure out, okay, could this be really bad? Now, we still disagree on that, depending on who you ask on the team. But
those considerations are definitely part of the discussion internally. That's what's driving this work. But at the same time, because how much can OpenAI's research team do on this? Great to have Daniel joining in, but I think it's also hard for that to be a huge factor in corporate decision making. It's really where you need public oversight getting involved in that, I think.
totally, yeah.
Okay,
Cool.
Thanks, Dan.
Thanks very much.
Okay, Frank.
Testing. So I don't normally apologize before I begin the talk. Usually it's afterwards, but I'm apologizing for at least 3 things. First of all, I'm suffering from a bit of a cold. I know everything was fine, but the drugs are wearing off, so everything's kind of getting a bit wobbly. So I apologize in advance for that. I apologize also for leaving halfway through the talk. I had to take a call for a lawyer. And the third thing is apologizing also because a lot of what I'm talking about today is going to be a bit outside of my normal area of expertise, but it sort of relates to some of the work that me and my lab and my companies have been working on, and just some thoughts about where I think some of this stuff is going in the future. So about 7 years ago, my grad students in computer science here at U of T and I, who are all working on natural language processing, we were writing papers on current status of natural language processing, and we were getting kind of bored and annoyed at just writing papers, presenting them to other computer scientists about how our numbers are bigger than their numbers, and then we'd go home and do the whole thing over again. So a bunch of us started thinking, well, there's got to be something more to this. Like AI, even at the time, even 7 years ago, AI was progressing to a point where we saw that there was some potential social benefit that some of our systems or models could play. And so we looked around, what areas are going to be most impacted in Canada in the next 10 years that we might be able to use AI to help alleviate. And very quickly, we came across the issue of aging. There's aging populations in various countries around the world, and Canada is no exception. And with age comes various disorders and disabilities, including increased risk of stroke, and in particular Alzheimer's disease. and other neurodegenerative diseases where, the brain shrinks and then people have reduced memory, but then increasingly reduced executive function. Alzheimer's disease is very difficult. I don't need to tell you that. And yeah, in Canada, we saw this is called the silver tsunami. It's like the aging population. The number of people above the age of 65, above the age of 85 is going to drastically increase. And, about 50% of the former group and about 10% of the latter group are going to have Alzheimer's disease in the next several years. So we thought we could help alleviate the situation somehow. The situation was that currently, if somebody was at risk of Alzheimer's disease, they and their partner typically would take time off of work, come down into a clinic in downtown Toronto or something like that, sit in a waiting room, being nervous about what they're about to go through, and then take a test or at least a screening assessment regarding their cognition, which is a pretty stressful thing to be going through. And not only that, but you also have to schedule nurses or other care workers to administer these tests, like the mini mental state exam or the Montreal Cognitive Assessment, which is basically this pen and paper, 2-page thing. You ask questions about, what day it is, can you name these animals, that sort of thing. And a problem for many reasons. A problem because, for the individuals who are being assessed, they have to, take time off of work and travel. Their spouse takes time off of work. It's very disruptive, very stressful. But also for the healthcare system, it's already a bit of, like nurses and caregivers are already are stressed, overloaded, and giving them extra work to do is not a good idea. Not only that, these tests are very bad. Even with a lot of training, the same person might administer the test in slightly different ways on Monday versus Tuesday, because some of the answers to these questions is very subjective. Sometimes you ask somebody what month it is, they say May, no, it's June. And is that right or wrong? They got the right answer eventually, but not initially. So our solution was we're going to throw the kitchen sink at this problem. We're going to extract a lot of measures of language that we could extract using our NLP tools. And we're going to extract it from kind of free-form speech and language. And the canonical example is get people to describe pictures for about 45 seconds to about 2 minutes. And then we extract a lot of things, a lot of measures that we thought were going to be useful and some that we didn't expect to be useful at all. So there's about 1,000 of these features, things including the frequency of words, the complexity of words, the complexity of your grammatical parses and so on. We did some basic statistical analysis showing that indeed there is a difference in terms of language between people with and without dementia. And we started doing this again 7 years ago before certainly some of the modern deep learning models really took off, but recently our group has been using transformers, usually in the form of BERT. We're up to about 100% accuracy in detecting Alzheimer's speech from non-Alzheimer's speech. I should mention at this point that the students in my lab went on to found this company called Winterlight, which was recently acquired, and I have stock in the new company, so it's a bit of a conflict of interest here. But separately from them, in my lab, we started trying to do some more things. Okay, if we're really good at assessing for cognitive change using language, maybe we could augment other things that some of these overworked caregivers are doing. We built a robot. I'm not sure if you can see on the left here. We built this robot at Toronto Rehab to basically follow people around the house and help them perform tasks of daily living, like making tea and that sort of thing. We also bought a robot called Ludwig, which we took into long-term care facilities and had the robot interact with the patients there. Ask them questions about their day, go through a couple of routine checkups and so on. And this work kind of continues, so I'll leave it there for a moment. I'll get back to it in a second. I left this work around 2018. I joined another company that focuses on machine learning in the operating room. There, we're not using language, we're using a lot of vision. So we have cameras on the walls, we have cameras on the instruments that are inserted into the patients. And we got a lot of these video feeds, and then my team's job was to use machine learning models to look for how the team's working, how efficiently the team's moving around the operating space, inside of the body, how effective the surgeon is with their instrumentation. And we basically, kind of like before with language and speech, we try to assess for how good or bad the performance was in each of these cases. And in this case also, there was a lot of, yeah, perfect.
Oh, sorry.
Sorry, just quickly. So how would you assess how well the team is doing? So morbidity or?
So there's a lot of issues. The main focus we had was on the performance of the surgery itself. So we had the internal view inside the body with the instruments There are a couple of different measures that are used in surgery, like OSATs, for example, where you're measuring things like the fluidity of motion by manual control. These are sort of standard ways that people assess for surgical skill. And we use those as labels. We build models to approximate those labels.
Okay, so like surgical success versus like patient outcome or something.
Yeah, and we kept on, so generally we had access to video in the room, we had sensory data for the patients, we had video inside of the patient. We could make, claims about the skill of the surgeon in terms of their technical motion. We always wanted to get outcome data that followed up, like how often this patient would develop sepsis, or how long would they stay in the hospital after they were finished with the surgery. And it was very difficult to actually get that kind of information. And not only that, but those kinds of labels were confounded by all kinds of things that we just didn't have enough data to approximate for. So it doesn't, it matters whether or not the surgeon is very skilled or very unskilled, but there's a lot of other factors like age and the nature of the operation itself that factored into long-term outcomes and morbidity. In both of these cases, in the case of automating the tasks of caregivers in long-term care facilities and in assessing for surgical skill, when we started taking these tools within these companies into hospitals and homes, we kind of heard very similar feedback right away, which is that's exactly the job that I do. There's some people in hospitals who literally assess lots of surgical data, and they assess for outcomes and they assess for surgical skill. And of course, they were worried that we were automating what they were already doing. And similarly, speech-language pathologists, gerontologists, neurologists, they were very worried that, well, this is, you're assessing people's cognition, you're doing the mini mental state exam for us, and that's not something that we like. So the routine response that we gave to people was that we're not really replacing your job, we're just giving you extra tools that will allow you to do your job more effectively. And that's always something that felt a bit, left a bit of a bitter taste in my mouth. It felt a bit like this is going to happen, you're going to have to live with it, and you're going to have to learn to love the machine somehow. So that's kind of the work that we've been doing. I've left that surgical safety company to refocus on my research in the university setting. But even in the university setting, in the past year or so, a lot of, in U of T and in Dalhousie, there's this big concern about how do we prepare students for a new job market in which GPT can program just as well as or better than you can. And again, just like we experienced when we were trying to get our machine learning models into hospitals, there's this refrain that you hear all over the place, which is that AI won't replace workers, that instead we're going to try to find ways to make people more effective. We're not going to replace people with AI, but workers with AI will replace workers without AI. The question is, which AI will it be? And everyone kind of talks about the one true transformer, GPT, which has gone through several iterations, and of course is the one that on a lot of people's minds. It's not the only transformer out there, and we'll come back to that in a moment or two, but it's relatively simple. The components of the transformer network are basically a couple of simple layers of adding a normalization. There's a little bit of multi-head attention. The real innovation of GPT is not in any kind of mathematical prowess. All they're doing is trying to predict the next word in a sequence and doing a bit of reinforcement learning in ChatGPT. The real innovation is the scope of this thing. So you're training these networks, these models with a wide variety of data. You're asking it to perform a wide variety of tasks, and you're not dealing with large language models with 12 layers of these transformer networks, but on the order of hundreds. And the results are pretty amazing. So there's a lot of questions about, language models are just stochastic parrots. They don't actually know anything. They can't reason about the world. And there is some, there's argument to be made for that, but there's also a lot of really interesting emergent properties of this particular transformer. So this is from an example by Sébastien Bubec, where he was trying to figure out, how does these models actually, how do they represent the world? So he proposed it with this problem. I have a book, 9 eggs, a laptop, a bottle, and a nail, and please tell me how to stack all of these things onto each other in a stable manner. ChatGPT would answer this way. It would be difficult to stack all of these objects on top of each other, which is correct. The book and the laptop are likely too large and heavy to stack on top of the eggs without damage, which is also correct. And here's where it gives its solution. Here's one possible way to stack all of these objects. First, place the bottle, the rolly bottle, on a flat surface. Then carefully balance the nail on top of the bottle, and then kind of stack the eggs on top of the nail, making sure that they're balanced and not tilting to one side. I tried this myself. I wasn't able to get the exact response, but this is the kind of response that ChatGPT typically gives. And obviously, it has no conception of like the curvature of the bottle or the curvature or the weight distribution of eggs and so on. But that was 3.5. GPT-4, just a few weeks later, or months, depending on how you count, responded to the same question this way. One possible way to stack the objects onto each other in a stable manner is place the book flat on a level surface, such as a table or a floor. This will serve as the base of the stack and provide a large and sturdy support, which is a nice explanation. The next step is now to arrange the 9 eggs in a 3x3 square on top of the book, leaving some space between them. The eggs will form a second layer and distribute the weight evenly, which is like a huge success, right? Like there's probably no text written that was provided to GPT's training that says this is how you should arrange eggs in a pattern in order to make them maximally secure to hold a laptop and a bottle and so on. But it was able to reason about the world in a novel way, which is really exciting. The main things I took away from this is that things are changing very quickly, on one hand. There appears to be a real model of the world emerging. So it's not just that the model learns how to spit out words in a way that is reasonably lifelike or natural, but it's actually doing something internally. And again, the third thing I was able to take away from this was when I went in, even to ChatGPT-4, I wasn't able to get these results back, which I'll come back to again a bit later too. Everyone, not everybody, many people seem to be very amazed by ChatGPT and GPT-4, but indeed not everybody. So Yann LeCun is one of the 3 horsemen of the apocalypse in AI, along with Yoshua Bengio and Jeff Hinton. And he works at Meta, and Meta also has a large language model that they're working on. Of course, he says, well, ChatGPT is not really that innovative and nothing revolutionary. So on one hand, like, you can't help but remember that he's at Meta and he has a competing interest in this space. But in the community of natural language processing, there's also a little bit of head scratching and like, questions about what this model is actually being able to accomplish. Like I mentioned a moment ago, on one hand, given the raw size and the amount and variety of the data used, these models are generalizable in a way that traditional AI was not. Like when I was a student, our models were able to produce text that sounded kind of like the Wall Street Journal or kind of like Shakespeare, but it didn't actually mean anything. So the fact that these models can reason about spatial objects is amazing. On the other hand, these core elements of ChatGPT are relatively old, individually quite simple. So it's not like a E equals MC squared moment, right? This isn't like a work of staggering genius, it's a work of engineering. Again, on one hand, these models are amazing. So this shows GPT-4's performance on Amazon's coding interview process. So if you're applying for a job as, I think, a junior developer at Amazon, you have to do some coding. And you get a score based on the code you submit, how nice the code is, whether it does what it's supposed to do, and so on. And GPT-4 was able to get 100% performance on this kind of interview step of the Amazon process. I'm not sure if you can see this down here, but humans are allotted 2 hours. So you're given 2 hours in front of a terminal to do some coding and then to submit that to Amazon as part of your application process. GPT-4 was able to get 100%, be better than 100% of all human users in 3 minutes and 59 seconds. And the reason they give for this is that you had to copy and paste the questions from Amazon into ChatGPT-4 and then copy the responses from GPT-4 back into Amazon. So most of these 3 minutes was spent by humans just copying and pasting things back and forth. So it's amazing. But again, on the other hand, we heard a little bit about mathematics and how these things aren't that great. So I was able to replicate this. If you ask GPT-4, what is 7 times 4 plus 8 times 8? And before we look at the answer, you can estimate in your head 8 times 8 is 64, 7 times 4 is 28, so the addition of these things must be less than 100, so you expect GPT to say some number less than 100. But it says 120, all right? Well, that's kind of weird. The good thing about GPT-4 is that it'll go on and explain itself. So it'll say, well, here's the equation. The first thing we do is we do PEMDAS, right? So we do the multiplications first. We can use parentheses to make this clear. So again, 28 plus 64, and then after that, you add them together, and you get your answer, 92. There you go. And then you go back to it, and you say, wait a second, you started off by saying the answer was 120, and then it says, that was a typo, sorry. I like this example. First of all, again, it's kind of amazing. The fact that it's an attention-based model. So when it says 120 initially, and it's printing up the rest of its text, it has a very strong prior that the answer to the question is 120. But as it goes forward, and it kind of explains itself, it comes to the right answer, and so it's able to reason the correct thing. So reasoning is great. It's really cool. But it's also BS, right? The fact that it says it's a typo, like that wasn't a typo at all. It's BS, and yeah, it's pretty human. I'm going to go a bit quicker now. I think we're running low on time. So yeah, there's been some really amazing work about the future of work and this concept of workers with AI and whether or not they will replace workers without AI. There's the first real-world study that I'm aware of, recruited 5,000 employees at Fortune 500 companies. And these were mostly people on service, call service. And their tasks involved getting customers to call in, and they're measured on how quickly the customers were discharged and how quickly it was done and how successfully the complaints were discharged. And they showed, this is a very early paper, but 14% improvement in productivity is in line with a lot of the other great work, and that's really impressive, like a 14% jump. The report, which you can scan here, also pointed out that about 83% of the subjects were in the Philippines and English was not their first language. So dealing with customer complaints in English and discharging it quickly in English was something that they would benefit more from an English model than people who are more familiar with English. And the same study also said, as we heard also, the more highly skilled workers saw little to no benefit from the introduction of AI into their work. Another report from Goldman Sachs, which is freely available, on the potentially large effects of artificial intelligence on economic growth, had a couple of quotes I want to share with you. So they say that AI can automate about half of the tasks in administrative jobs, legal jobs, architecture, and engineering professions. And in first world countries like the US, UK, Canada, up to almost a third of the country's workforce will be completely automatable by AI. And they said that the least threatened jobs are the labor-intensive jobs like construction, installation, repair, and maintenance. So I translated some of these. So I think according to this line of thinking, like we're all expendable, right? Like Goldman Sachs seems to be frothing at the mouth, trying to get ready to dispose of people as quickly as possible, and a third of people are disposable. And what we often don't think about in settings like this is that some of us are probably going to be expendable also. Even people with tenure in university, we have to worry about like how we even train young adults in computer science to do programming. So we're not immune just because we happen to be talking about AI in a venue such as this. AI will make art and write poetry while you do hard labor, is another outcome of this. Near the end of this report, they have a couple of caveats. They say that increasing the number of jobs displaced, so the number of people who are going to be fired, from people just kind of augmenting their workflows with AI, to having a large proportion of the workforce being displaced, will increase productivity from 1.2% per year to 2.4% per year. So in other words, like it's going to be good to fire as many people as possible because you'll get a return of 1.2%. So yeah, replace as many humans as possible to maximize growth. And the other outcome is, productivity growth is estimated over 10 years, but if it's stretched over 20 years or 30 years, the benefits to productivity, to economic growth will be diminished by a half and a third. So, like reading between the lines, I read that as like they want us to replace humans quickly to maximize growth. Now, this wasn't written by computer scientists. It's hard to tell how accurate any of these predictions are going to be. Is it likely to happen just because Goldman Sachs says it's going to happen? And part of me thinks that, yeah, maybe, right? Like already the CEO of IBM said that we're going to put a freeze on jobs that can be automated with AI, and potentially we're going to replace almost 8,000 jobs that also can be replicated with AI, right? And this is so soon after ChatGPT sort of just came into the public consciousness. There is a eating disorder helpline where people call in and they talk to a therapist about issues related to eating disorders. And the helpline the therapist unionized, and then at that point they were all fired and replaced with the automated agent. So there's like this, like it's not surprising. Like I think not only does Goldman Sachs recommend that this happen, but there's like this hunger in industry that like we can cut costs if we just get AI to do our work for us. And like, why is this happening? This is where it's totally outside of my area of expertise, right? I'm a computer scientist, but like some of these concepts like matter to me. So like, I'm interested in hearing your opinions about some of these things. But like, I think we're all aware of like how Amazon is known to treat its workers, right? So they have something, these watches they have to wear, where when you're stacking things, like you're not allowed to take bathroom breaks. And if you take these micro rests, they call it micro rests, just to catch your breath, or even just to plan out your route through the fulfillment center, you get penalized, and some people get let go because they want to be humans and breathe and just take a rest, for example. So like work is already pretty bad for these people who are at risk of losing their jobs. Okay, so Amazon.
So just that was a really interesting sentence. So I want to think about it for a second. Work is really bad for the people who are going to lose their jobs. You know, do we have a sense that there's? I don't think we have a sense that there's fewer jobs in the economy. So that seems like a good thing. Or am I missing something?
I don't know. So I mean, it's not a unidirectional thing, right?
Yeah.
So it's not a matter of like there's unemployment and then there's like misemployment, right? So you have a lot of people who are working, but they're working often in part-time jobs and jobs they don't care about. You have people who could be great physicists working in service industries just because they have to be able to pay the rent. And there's more of those kinds of jobs. Whenever we have a job report where like the unemployment's going down, most of those jobs are these part-time jobs filled with workers that are
Okay,
here
I'm not,
temporarily.
I'm not sure that's true, but that's something to talk about later. Okay.
I'm thinking more about jobs that people's whole lives revolve around. Say if it's their entire personality. I know that there are people out there like that. And for them to see something that they're so passionate about, they've been working out for their whole lives. And then I'm thinking about the question of value. Does the value come from just the skills that they provide to the corporation, or does it come from an intrinsic desire to keep, providing value in terms of passion, if that makes sense?
Okay, I just want to sort of remind everybody, so we're in an interdisciplinary conference and we all have particular expertise. So let's just make sure in responding, we stick to, we're careful to talk about what we really are experts in. Like, I'm not an expert in what you just described at all, and what we're not.
Yeah, so exactly. I'm not an exact expert. I'm a computer scientist who works in natural language processing. So my naive sense as just a regular person is that like a lot of people do, like they care a lot about the work that they're doing. And like I did not get into computer science myself in order to get a job, or I didn't get into AI because I loved AI, because I wanted a job in AI. At the time, there were no jobs in AI. AI was still sort of on the fringe, so I really cared about this work. Yeah, I'm not an expert, so I don't know much about the statistics of how some of these jobs are being replaced. My hope is that there's this strike happening in California for the writers, right? Like they're not writing just for the work; they write because it's a passion of theirs, and it just happens that the companies they work for, value some of their work to a certain extent, so they'll pay them to write scripts for TV shows on Netflix or something like that. But it might not be what that individual wants to write, right? They're working for the man, right? Hopefully, people are able to separate out work from passion in some way. So people can write poetry, people can code AI, but they can do so in a situation where they're not working, 8 in the morning to 6 at night in a job that they hate.
Yeah. Okay. Thank you.
So again, this is the main point where like I'm not an economist, so like this is I'm just relaying information that I found on like wage stagnation and the nature of work currently. So like what is work like for people who have not yet been replaced by AI? And this graph over here shows wage is basically stagnant over the last 20 or 30 years.
But Frank, this precedes AI, right?
Exactly. Yeah. Okay. So like, I'm kind of saying this is the context of what we're living in so far. Of work, and when AI comes into it, it either is going to disrupt things massively or it's going to exacerbate trends we're already seeing. And what I'm suggesting, from my point of view, is it might be more likely that it's going to exacerbate trends that we're already seeing.
And this is from your experience working and trying to implement?
Pardon?
And this is from your experience working and trying to implement in hospitals and elsewhere?
Yeah, this is from what I'm aware of in terms of like what the data has been saying about the nature of work so far.
So, right, so I just want to make sure that we're all on the same page here. So what you bring, like the experience that you have is you've actually tried to do this. And in your experience of actually trying to do this in a workplace, what have you seen?
We can jump to that if you want.
Okay.
I'll skip over some stuff, which I nevertheless think is important to think about. I'm talking from my point of view, right? So most of these things are like how as somebody who's been trying to take the axe into the forest, how does that feel to me as someone who might be displacing work? And there's this quote that I got the title of this talk from. When the axe came into the forest, the trees said, "At least the handle is one of us." So I feel like I'm the axe. You know, as people who are working in these jobs, they're working very hard, and you know, they're struggling to meet quotas or to fulfill their the amount of work they have to do. And then I come in and I say, "Here's something that can replace you." They didn't get into surgery or medicine just for the money. They got into it because they cared about it. In my experience, a lot of them are overloaded. They lose their passion over time, like in family medicine. They got into it with noble ambitions, for example, but then they get overloaded with tons of paperwork and calls with lawyers and so on that is really separate from what they thought they were going to be doing when they got into it. So when I come in and say that we're going to automate what you're doing, you know, sometimes like family doctors are happy about this. They think like a lot of what I do is charting, and if you can just automate that part of it, that would be great. But it's the other people who are assessing individuals, looking at surgical skill, watching how a team's operating in an operating room. Those people I often feel a bit guilty for because even though it's possible that their work will be augmented and they'll be able to do things they really care about, I have this nagging sensation every time I go into a hospital that they won't have that opportunity, that they're going to be let go. And the reason I think they're going to be let go is because what I'm aware of in the world in terms of how large organizations tend to treat the workers who do most of the hard work. So in terms of someone who works in natural language processing, there is this notion that a lot of companies are going to ChatGPT and they're going to be trying to automate as much as they can with GPT. And that is also something that's concerning to me, right? As somebody who's been in this kind of ecosystem for a while, I want to see a healthy ecosystem of Canadian companies building, managing diverse and homegrown intellectual capital, data staying in Canada, building skilled workforces in Canada. And if we're just letting people go and offloading all of this work to ChatGPT and sending all of our data down there and all of our capacity down to a couple of Californian companies, this is going to be a problem. So this is a bit of a false dichotomy, the fact that either you have a healthy economy of small companies and developing talent locally, or this monopoly of AI, generative AI. But there is this real spectrum that's kind of occurring between these sort of extremes. I think sometimes regulations will answer these kinds of questions in some cases. So we just can't send patient data outside of Canada. And some companies also are concerned about IP. They don't want their code snippets to be sent to GPT, and that's a problem for IP. So it might not be much of an issue in the short term. I want to suggest that some companies that are relatively large in Canada might be being gaslit somewhat when you talk about the apparent cost to train GPT-3 and GPT-4. So GPT-3 supposedly takes about $12 million to train on hardware from 2021. GPT-4 might have 500 times more parameters. This is part of the marketing that's being done by ChatGPT and Google and others to say that you can't do this on your own. This is way too expensive. You're not going to spend $12 million or $500 million on training your own models. You have no choice but to use us. Now, first of all, there's alternatives to GPT out there. But when I see generative AI, which again is something I was working on for a long time as an NLP person, get into the public sphere, I kind of, my back goes up against what I see as marketing, right? Here's other examples of what AI marketing looks like. So recently Google was interviewed on 60 Minutes, And it was claimed that Google AI's program can adapt it on its own after it was prompted in the language of Bangladesh, and now it's able to translate all of Bangladesh. So on 60 Minutes, it was claimed of Bengali. So on 60 Minutes, it was claimed that these modern models are so amazing that they can automatically figure out how to speak Bengali, even if they were never trained on Bengali. But as people who used to work within Google pointed out, that's not necessarily the case. Even if there's a small amount of Bengali language in some of the training data, these models are still trained with Bengali. So there's a lot of hyperbole that goes out there. And finally, I'm also kind of wary of how, like what kinds of people are going to be calling the shots for some of these models going forward. People like Elizabeth Holmes, Bankman-Fried, Elon Musk are the ones who gather a lot of attention and a lot of money. And they're the ones who are typically the ones who decide how these models are going to be used in practice. They steer the ship, and it's also something that I'm concerned about.
Wait, Frank, aren't you steering the ship?
No.
I'm just trying to understand this. Like, you're the guy developing the technologies that are being deployed. I think I get what you're trying to say here, but think about where you sit and what you're doing. How does that fit in?
Compared to the power that Elon Musk has in this world, I am like a speck of sand on the beach. And I think most people who work in this area are, right? Like there's a lot of conferences, a lot of people work in generative AI. We spend a lot of time, a lot of effort. We care about this stuff. We talk about how to make sure things are free of bias, how to make sure they scale and everything like that. But at the end of the day, the people who call the shots, the people who run the companies are people like these.
But no. You're running a company.
No.
Or you were, right?
I run small.
And there's
little
thousands of
companies
people
100
like you.
people. Yeah.
So what am I missing?
Yeah, I mean, it goes back to the idea of the monopoly, right? So there's a lot of companies who are working on generative AI, and we're building things with BERT, which is something you can run on a single GPU on your own computer. And we put a lot of effort into making these systems, be 5% better at recognizing when a patient is belligerent when they come into the hospital. And that is, so we spend a lot of effort, a lot of time, as much money as we have in our small little companies to make that happen. But then you have these massive companies like OpenAI come in and say, look, this is a company of 20, 30 grads from the university. All they care about is research. They don't have a team such as ours that has, quality assurance. There are the magnitude of our data. Like, of course, if it comes down to.
So was that your experience that there were people that when you were trying to sell in, you got outmaneuvered by the large tech companies?
We were lucky. So, I mean, we started some of this stuff before OpenAI and BARD and some of these technologies sort of came on the scene. So there wasn't really an alternative to us. And even still, we built systems to do speech recognition. We were relatively happy with our performance on, disordered speech. But there was, Google had a speech recognition system that was like 20% more accurate than us on general speech. But general speech wasn't our niche. Our niche was older adults who have speech disorders, so we could maneuver around them and still get a little bit of traction on the order of contracts worth $100,000, $200,000 a piece, sort of thing. But these technologies are growing very rapidly. So now I don't doubt that GPT-4 and certainly GPT-5 would be probably better at doing a lot of the tasks that companies like the ones I had founded before and other companies that are trying to emerge out of U of T and other institutions. There's going to be a really difficult time competing, right? I was lucky because I wrapped up things before this happened, but if somebody can get better performance by doing a single 10-cent API call to ChatGPT than a team of researchers can with a fancy $1,000 GPU, then companies are not going to choose to go with small companies, ones without QA teams. So I'm concerned. So most of what I'm talking about here is the concerns about monopolies and the lack of competition that we're going to experience in the near future unless we're very careful about it. Yep.
Yeah, isn't that a good thing though?
Monopolies?
No. If you can get access for a 10-cent query.
Can you talk into the mic?
Yeah, sure. I might have turned it off by accident. If you can get access for a 10-cent query, and lots of companies can build on top of those queries as well, you've created a competitive environment with tremendous access for lots of people, as opposed to having to deal with you. $100,000 is a lot of money for a lot of contracts. So, it's kind of great, right? Like, there's the monopoly concern, but we can deal with monopolies.
So I think my main thing is we have to deal with them, right? So I also, I mean, I'm not a fan of monopolies, right? So like I have a bit of a bias against this, but I kind of prefer the idea that there's a healthy ecosystem. I care about students in universities who have great ideas and they want to start their own company, and I want them to be able to succeed, and not only in Toronto and in Canada, but everywhere. And I want new ideas to be able to flourish. But the monopolies have known problems that they.
Great. So can you tell us some, like that sounds like a story that we need to know, which is the students that have these good ideas that aren't able to move out of the university because the technology, their competition is now too fierce. Like, it's weird to think about it as monopoly, but essentially what's happening in the tech companies is too much better than what we can produce in the university. Because that's a key part of the story and a key part of your experience.
Yeah, exactly. So the question is, like, what do we...
Yeah, so the technology you developed was developed a long time ago, so it makes sense that it's not, cutting edge right now. The question is, are your students struggling to develop, to commercialize what they're building now because of what's going on?
So my sense from talking to a lot of upper year undergrads and grad students is that they kind of have the blinders on to some extent. They still imagine that this isn't going to be a massive problem for them. So there's still a lot of small companies that are coming out of research that was done in the lab in the university, and you have like these little ecosystems that are still relatively flourishing pretty well, and that much is like positive. But I just so I'm just talking from my personal point of view here. I'm just concerned that the party's going to be over at some point. When literally researchers, people like Goldman Sachs are saying no, half of jobs are going to be replaced in the next 10 or 20 years. And these machines are getting 100% scores on coding. They're getting 70, 80, 90% scores on bar exams. Like there's no job that's going to be safe. I'm not saying it's going to be the case, but it's something we need to think about seriously.
Yeah, so I think this is why we want economists in the room, sort of making the point that it's actually really, really hard to predict. And you could not have predicted at the end of the 19th century, when somebody gave me the right answer, 90% of people are working in agriculture, what was going to happen to what all those people did, right? And then a big chunk of this, Daniel, we've talked about this before, actually a big chunk of it was like we created the regulatory state, and a whole bunch of people went into the business of being in the regulatory state. So there's a whole bunch of things coming. But I think just thinking about I think about, it's a foundation model, right? I mean, I think it's a pretty good term. There's lots of things you might change about it, but it's a general purpose technology. It's something you build on top of. And I certainly in a lot of my regulatory conversations, I primarily say this. They don't think about your concerns about raw chat GPT or raw GPT. Think about what you're going to build on top of it. So I think about the two things you started with, right? That's knowing what to build and what to build on top and where it would be valuable, and then running, the innovation is how do I make this work for people? Because you gave a great story about how difficult it is to get evaluated in our current processes. So, but I'm guessing it's not as simple as, let's just send everybody a link to take this test. There's probably all kinds of human supports that need, a different kind of human support that needs to go around that, which you may be able to afford because you're not spending your time trying to get people in. Same thing with I'm really just the following what's happening in the surgical suite. That's also real domain expertise about, and just that real, okay, what do we build? And I don't think OpenAI knows what to build, and DeepMind doesn't, well, maybe, I don't know. Do you know what to build? You guys know what to build? So I would say, like, for your students or for the tech startups and the innovative community, it's like, and I think Daniel showed us this, the calls on, just the spike, right? I mean, that's, as you said, that's, if I understood, it went by quickly, but That's a whole bunch of people who say, oh my God, look what I can build now that I can do a call on GPT-4 or whatever for a piece of things that before I had to figure out how to code myself. And as somebody who doesn't code at all, it's kind of exciting, that piece of things.
Okay, I'm just noticing Frank has about 3 minutes left. So I just want you to wrap up based on your experience and expertise on how to think about AI and workflows.
So yeah, there's a lot of unknowns here, right? So what I'm providing basically is my point of view at this point in time about things that we need to be a bit concerned about realistically. And it's one thing to talk about numbers and estimates, but we don't know what the future is going to look like, and we need to actually do something in the real world to engage with some of these technologies. There's this quote I like: the science gathers knowledge faster than society gathers wisdom. So I think that's kind of where we're at now. The technology that we have is something like we've not been able to have before, and but we don't know how to deal with it. And I have lots of concerns as a human being that our lack of understanding of these technologies at a societal level and the biases and the inequities that already exist in society are going to blow wide open unless we act seriously about it. And I don't know if, as a society, we're going to be able to do that. From my perspective as a computer scientist, I'm also concerned about kind of things in computer science. There's another quote I like, which is any discipline that needs to use the word science in the title is not using science. And it was said about computer science that we as computer scientists aren't real scientists. We're just doing everything in a discovery-based thing. We have a model, we tweak it, we see what happens, and then we report on what happens. And it's also the case that a lot of computer scientists, we just don't have much or any real formal training in empirical methods. So there's not usually a null hypothesis in a computer science paper, and computer science papers very rarely say, I was wrong about this, or this approach didn't achieve what I hoped it to achieve. It's a wholly other thing, right? So if we're going to tackle these problems of these models scientifically, we need to have better scientific treatment, and computer scientists need to be trained to focus a bit more on the science side than the computer side. The other problem with GPT is that it's kind of impossible to reproduce the results. Like even when I put together talks like this, there's an example that I wrote on one week, and then I try to reproduce it on another week, and I get very different results. So if you're a company or if you're an academic, this is a huge problem. So reproducibility, robustness, and control are things that every company needs to be able to have. And if all you're doing is you have one single API call to ChatGPT and what happens behind the scenes changes from week to week, then that's going to be a huge problem for any company that has no choice but to rely on this monopoly. From a scientist's point of view, we want to be able to dig into these models and understand how they work. Our lab does a little bit of work in explainable AI. We need to be able to do ablation studies to swap things in and out, to dig into the models themselves and to understand what is actually being learned. And it becomes very difficult if all we have is kind of quality assurance for OpenAI, right? So what happens when you say this to a ChatGPT, this is the response you get. And that there's a lot of scientific validity to some of that, but there's a limitation to what we're able to do as well.
Rich?
I want to touch on one more thing. Yeah, this is off topic a bit also, so I want to be able to say this. Oh, you have a question?
Yeah.
Hello. I don't get it. Why don't you just stand tall and do good science? I mean, you're sure there are these obstacles, but you can get around them all. You can get a version of ChatGPT that sits on your laptop that doesn't change. That's all these things are, and I agree. Computer scientists are not really good scientists, but we can change. We can be better scientists. That's what should happen.
So that's exactly my point. So
You say it's a dystopia, but aren't you saying? I mean, it doesn't have to be a dystopia. What are you saying? That it is a dystopia, or
I'm saying that dystopia is emerging and it's on the horizon, and we need to be careful about it.
Dystopia is coming.
Yeah. So there's the ACL conference is coming to Toronto in about a week and a half, and recently a lot of the papers that we see at the ACL conference are there's these trends, and last year a lot of people were basically just sending like what I was showing in these slides, examples that you can send to ChatGPT and what happens when you get back. And then you try to evaluate, does the model understand pragmatics or syntax? How is it able to translate between languages? Is it able to have a theory of mind? All those things. And there's a lot of great science you can do on that front. but it's also becoming very limited, right? So it's kind of like if you had a room full of the greatest physicists, that their papers were all about how do you send queries to Google in order to get really good responses. That's not really good science, and that's sort of where I see the...
I feel you could say the same truths and say, oh, this is an opportunity. This is an opportunity to do good science, because there are many people that aren't doing good science, so if you do good scientists, you can win.
And I would argue that much of what we saw yesterday were experiments, with, that were reproducible and really interesting. So, absolutely. Okay, you have 30 seconds to wrap up because we do want some time for discussion. So maybe this topic can.
I'll just end with this. So like the future of science and natural language processing can take a couple of different paths, right? So on one hand, we have a black box models that you cannot open up in query. So as somebody who works in natural language processing, I want to open up these boxes, I want to tweak them, I want to modify the model, or be able to anyway. And if all I have is this box that I can't modify whatsoever, it severely limits what I can do as a scientist. There are models, like you pointed out, that do run on your servers. So there's Llama and Alpaca, for example, which our lab is working with, and of course all of the BERTs. So there's still kind of a sandbox that we can play in, and we can still do the traditional kinds of real science and language models. But
okay, we really got to stop for a panel. Okay,
thank you.
Thank you. Okay. Sorry, just I want some time for the two of you to be able to talk, and so maybe we'll go to the. Right, we got a question from the audience.
I work for LinkedIn, but I'm not speaking on behalf of LinkedIn or Microsoft. But I will briefly refer to a bit of research that we do that's more relevant to the work that Daniel and I think Abby do. In commenting, we had a research project here actually in Toronto about 6 years ago that we brought the mayor and a bunch of colleges and the banks into, where we were trying to figure out how to get folks into jobs really fast. And what we looked at were the skills that were most in demand and that you could teach really fast. And so a bunch of the colleges spun up boot camps focused on, at that point, Adobe Flash. We were the Flash capital of the world for, I had no idea, but there was a lot of websites made with Flash. And about 6 months later, Adobe discontinued Flash because on mobile, it was no longer functional. And that's, I think, a perfect example of why LinkedIn rarely predicts more than 6 months ahead of time, maybe a year, because it's really hard to look at ONET data or our own skills taxonomies and predict future jobs. It's also why I think most of the research in this area, to be frank, is pretty lousy. I think it often does involve predictions, even when it starts with the sentence, we don't make predictions, like I just did, and then goes on for many pages to describe alternate worlds. On the other hand, I really appreciated the second and the last presentation, which I appreciate has also gotten a lot of criticism, in part for its critique of monopolies and capitalism, as opposed to a critique of ChatGPT or AI. And I wonder whether that might be why there's so much confusion right now, i.e., sure, ChatGPT is further concentrating power amongst certain organizations that have been concentrating power for over a decade now, maybe two. But is that the critique, or is the critique of the technology itself and its impact on the economy?
Okay, so maybe we'll. So let me start with just a quick reaction to what Dan's paper does really well and really carefully is it says exposed. And I actually think that's the right way to think about it. Exposed is right. It's a little bit, really that's the best way economists can do, exposed, but it is. And that's, understanding that is really important. Exposed could mean fantastic, it could mean awful. It's at the 80th percentile. The internet and computing exposed the 80th percentile as well. That was awesome for people in the 80th percentile of the income distribution. I actually have a paper thinking this isn't going to be so good for the 80th percentile, but it's going to be great for the 20th. But we don't know. And once you recognize that story on Flash is really interesting. Another thing I just want to clarify, what I find so exciting about Frank's work is that he's going out and trying to make this happen. The ex post angst that he's experiencing, I didn't anticipate. And I find that fascinating. And I was trying to connect, it wasn't necessarily a critique, but I was just trying to connect it to, okay, this is like your macro political philosophy point of view. In your experience on a day-to-day basis when you were building these tools and trying to implement them in workplaces, How do I connect you? How did that inform this political philosophy that you spent the last half of the presentation focused on, as opposed to computer science, which is in the first quarter?
Yeah. So can I talk to both of these points?
Yes.
So, I mean, like, I think one of the apologies I gave at the beginning was that I'm going to be reaching out outside of my comfort zone when it comes to what I wanted to talk about. You know, I could go on and on about models and how I interrogate them, but in a setting where we're supposed to be, you know, multidisciplinary, I wanted to kind of just put out there, this is kind of what I'm feeling, and I was actually hoping that people would correct me a bunch of the time, because I'm very naive when it comes to a lot of economic theory. But like it's my point of view, right? Like I don't want to replace people's jobs. And ever since we started these companies, there was always this, you're going to automate this and this job will be obsolete, and maybe they'll be replaced by something else. But it's just been eating at my soul, for lack of a better word, for a very long time. And I don't want to have half of the population, as some people estimate, being on POGI because they got the...
Dan commented on that Goldman Sachs study later. Okay.
So I don't necessarily believe that what Goldman Sachs put out there is going to be the case, right? But the mere fact that people are putting out those numbers with a straight face, and you know, and then companies like I mentioned IBM and that helpline take action right away and start replacing people. Like the stuff that I wanted to avoid seems to be actually happening on a broad scale, and to an extent much more serious than like me, you know, augmenting, which is essentially what we were able to accomplish, the work of like 1 or 2 people in a hospital with like wiping out thousands of jobs. So you know, yeah, it's a bit of a personal voyage for me, or a personal point of view from somebody who's been working in this area. But I'm just super concerned, and I'm worried about like the low-level workers, right? So like the fact that I can get a front-end, you know, like web app myself. I'm not a front-end engineer by any means, but I've worked with a bunch of them, and I loved working with them. And they cared about design, they cared about you know, producing interfaces. But those are the jobs that are going to be potentially replaced first. And I just I hope that we have some, as a society, we can develop some safeguards so that, you know, we don't have this dystopian future that could potentially happen.
Daniel?
All right, well, so first of all, on the Flash thing, it's super interesting. Also, I've worked with the LinkedIn Economic Graph team a bunch. They're wonderful, great group of people. Flash thing, there's a great paper by John Horton and Sunny Tambe precisely about that. You could thank Steve Jobs for killing Flash. All right, so on the Goldman study, candidly, like I'll go on record, it's not a good study. Like this is, you know, I've, for whatever reason, been talking with a bunch of different investors recently. Each one of them have gone and talked to those people, and they don't believe the results. So saying 40% of people are going to get automated with current technologies in the near term, I'm 95% sure that's nonsense. Now there's like, I have a wide confidence band on what these things can do, so maybe I'll be surprised and something will change. But yeah, I don't think we have to worry about large-scale, long-term technological unemployment. And the great news there is that we can make policy changes that help people who are displaced. Like, you know, whether or not technology caused worker displacement, whether people are down on their luck because it's technology or something bad happened to them, they have a health issue, it shouldn't matter. We can build policies that help them get back on their feet. I think these claims by like CEOs who have oddly specific numbers of people they'd like to fire, blaming it on things like GPT seem like saying it's not the higher interest rate environment or the bad decisions we made, it's the fact that there's this technology we can replace people with. And maybe that's part of it, but I think you can probably rest easy. It's not, you know, there's lots of different things people do in their work, and when you introduce something that helps expand access and get better results for people, we shouldn't be upset about that necessarily.
So I guess you're saying it's like every time we've used automation before in the past. Or it's not totally different anyway.
Every single time this happens,
That's the
people make
cliche.
that argument, right?
Cliche is that we get automation and the jobs change, but the pie gets bigger and we win.
Yeah, I think that's likely. Every time we have this happen, there's an argument over whether this time is different, and I haven't seen compelling evidence that it is. I mean, we have very low unemployment right now. Maybe that changes rapidly in the near future. I think we should prepare for change for sure, but like, I don't think people are losing their jobs.
One important nuance on that. So Jay Joshua and I have a new Brookings article on this, which is, so mass unemployment, like that's it. Maybe this time's different, but it's unlikely. But general purpose technology, by general purpose technology, some end up increasing inequality and some end up decreasing inequality. And that remains an open question about what's going to happen with AI. Is it going to empower skilled workers, augment skilled workers, or is it going to augment people who are currently not at the top of the income distribution? And the internet and computing, which many people think of as augmentation technologies, they were, but they augmented people at the top of the income distribution and made them do even better. Electrification and some earlier technologies tended to augment people who were at the lower end of the income distribution. And we hypothesize, and I want to be very clear, it's hypothesize. We have no idea what's going to happen in principle. We hypothesize that many of the recent advances in AI look more like electricity in terms of augmenting people in the lower half of the income distribution than the top half. But but reasonable people can disagree on that.
Unless there's somebody else, because I've spoken a lot.
There's no one else behind me.
Okay, all right. So I think we can focus. Yeah, we don't know what's going to happen. I think that's really important. So I think it's not, we don't know that. Like I'm also very worried about the monopoly piece. Like, what are we seeing about capitalism? I think there's short, medium, and long term. There's transition, and then there's just total transformation of economic systems, which is kind of where I think we are. But I want to say so I think about legal work. And I've been watching, GPT. I'm working with some of the same people, Sam Manning and Pamela Mishkin, to do a study to compare actual legal work. Here's the billing data from what law firms charge for this work, and now we're going to give it to GPT. So we're going to have those direct comparisons. Really looking for. But I talked to one of the law firms that was beta testing this is for a product built on top. Again, as domain expertise, co-counsel. And I sort of joked it, over drinks at a conference. So, how many of your junior associates have you fired so far? And he said, oh no, we have more work than we can possibly do, because there's so much area under that demand curve. There's just tons of people who don't get, it used to be, whether it's your person getting evicted from their housing, which is not getting the tool because it's only being sold into corporate law firms right now. But the CEO calls and said, my top engineer just came in and said he's leaving to go to this other company. What can I do? Right now, I'm saying, well, I'll get back to you, few days, few weeks, or you could pay $2,000 an hour for immediate, good, top of the mind response from the partner. But now what they can do is say, give me 15 minutes, and I can get a pretty reliable first take on a 17-page memo on this. So there's just a ton of work that can be done that we don't do now because it's too expensive to do it.
I love that. So one way to think about it is there's potential expansion of demand for lawyers. But even if that doesn't happen, it's not obviously a bad thing, which is that
I'm not worried about lawyers.
The costs of interacting with the regulatory state fall dramatically. That's going to be fantastic in many ways, both for our ability to regulate and for those people who can't afford access right now to law. So there's these, when we start thinking in terms of equilibrium forces, we have these challenges on disruption in one particular domain is bad for the people in that particular domain. And to Dan's point, any kind of disruption, whether it's technological or otherwise, but when it creates opportunity to deliver something of value to society, that's wonderful.
Yeah, so the
Yeah.
cost
I
coming
know you've
down
thought
is a
about that more
really
than I have,
important
so-
thing. It's a really important thing in a lot of domains. And I would think in medicine as well, right? That's what I hear as part of, again, that first story about the aging population.
Well, one thing that I don't know about, but I would like to learn about, is how this sort of technology might change the wage gap, right? And the changes in wages. So I don't see a way that a worker who says, okay, we're not going to replace you, but we're going to augment you with some kind of automation, like, why would that person be paid more than they're currently being paid? And especially when what they're currently being paid is no better than what they were getting paid in the 1990s or earlier, right? Like these people who like, okay, now you have ChatGPT, but and suddenly all of a sudden you have enough money in your pocket that you can buy a house in Toronto. Like I don't see how that could happen.
Oh, well, I can give you an example of that. I mean, let's take the legal services one, right? If you, as a junior partner now, can produce memos that, are as high quality as what the top tier partner would have done, much faster, you can start your own law firm and serve, 2,000 clients at scale. Your marginal productivity is what you get paid for in this circumstance, and that's going way up with the technology.
Yeah, it seems like a lot of the benefit's going to happen at the organizational level. So companies, even a company you start yourself, if you're successful, and that's a big if, then there's going to be benefits there, and there's wealth to be gathered up. But like, not everybody is going to start these companies and have 2,000 clients.
You're going to get comped based on your best alternatives, right? So when the market for your services, even across organizations, gets more competitive, you're the scarce complement to something that got rapidly cheaper. That's good news. Let's see some questions over there.
Yeah, so I was thinking about my former employers at McKinsey and Company. There's not going to be any destruction of value generation at the bottom. The partners at McKinsey, all of their efforts and the efforts of the firm for 70 years has been to get more out of the lowest levels so the partners can spend more of their ridiculously compensated time in direct conversation with the CEOs. So people are just going to move up the pyramid faster. They're going to move up the value chain faster, and McKinsey will continue to dominate the world.
Yeah, I don't think people are too worried about McKinsey or BCG. If not, they're the consultants, right? So they should be able to figure out how to help themselves out too.
A question about agency, because I feel like a lot of the conversations sort of act as if ChatGPT is acting on its own or spreading on its own, just as the changes to the labor market are happening on their own, as opposed to having humans create those changes at McKinsey or elsewhere. And I guess I'm asking two economists and a scientist how you would recommend we take more agency with the very limited amount of knowledge we have about what the impact of ChatGPT is going to be. Is there something about the introduction of AI that gives us more control over how the labor market is going to be in the future in a way that might solve for some of the problems raised in the last presentation? And if not, that's fine too.
So I'll take it first. So a lot of it is, it's an important message that you have no idea what the labor market impact of the technology you're developing is going to be. And what I mean by that is you think you're augmenting somebody, and in the process you might automate a whole bunch of other people. Or you think you're automating somebody, and in the process you might augment a whole bunch of low-wage people. That's a, I don't know, kind of answer. And so a version of that is try to think through the applications that on the end user side are going to create the most value. So how can you develop technology that can help the most people once the technology is working? And then if you broadly think about the general equilibrium effects of that, that should be good for everybody. And then there's going to be disruption. Like that's consequential, and you absolutely deal with it. But that kind of technological-based disruption isn't different from other kinds of disruptions in terms of the policy implications. And if you're developing a technology that can enable millions of people to access medicine in a way they couldn't before, or millions of people to access the law in the way they couldn't before, that's going to be, there's reasons to think that's a net positive.
I'll add, this is a small additional point, but something that some co-authors and I have been working on is using large language models themselves to understand the labor market. So you can take, we have hundreds of gigs of job postings and look at which jobs are similar, why they're, might be different. How do you move through this space? So if you do see an area that you've picked up on is okay, these people are really suffering, you can spin up a program of some kind to move people from one spot to the next. And that's costly, it's difficult, but at least we can see like where there are more exit doors or exit windows if the doors are being shut, and where people are more at risk. So these tools can be used to help improve the labor market as well. Econ's highly exposed as well. So.
Okay, I think we're out of time. So
Yes.
thanks everybody.
Thanks.